In this lecture, we shall study about the asymptotes to curves. We shall study what we mean by vertical asymptotes, horizontal asymptotes, and oblique asymptotes. And we shall also describe the methods of finding these asymptotes with an example. Okay, now let's take the definition of an asymptote. So here we include the definition. An asymptote of a curve is a straight line such that the distance between the curve and the line approaches zero as one or both of x and y as one or both of x and y coordinate tend to infinity. So geometrically we can think of an asymptote. It is a straight line that behaves like the equation of a curve at x equal to infinity or at y equal to infinity. Now here we first describe there are three different types of asymptotes. So there are three types of asymptotes. The first one is vertical asymptote. The second one is horizontal asymptote, and the third one is oblique asymptote, or this is also known as slant asymptote. Now here at this stage, before writing down what we mean by vertical asymptote, horizontal asymptote, or oblique asymptote, we shall describe all of these using one figure here. Now let's look into this graph. If we look at the first graph where we are describing this vertical asymptote, and we try to understand the relationship of the lines x equal to pi by 2 and x equal to 3 pi by 2 with the graph of this curve. Now first, if we look at the line x equal to pi by 2, now we can see this line gets closer and closer to the curve when y approaches minus infinity. So therefore, the distance between the line x equal to 3 pi by 2 and the curve approaches 0 as y goes to minus infinity. Now on similar lines, if y goes to plus infinity, that means y increases, then the distance between this line x equal to 3 pi by 2 and the graph of the curve, they approach 0. So we can see that the line x equal to pi by 2 is a vertical asymptote to this curve, and x equal to 3 pi by 2 is also a vertical asymptote to this curve. Now second, let's look into this second graph where we are describing a horizontal asymptote. If we look into this line xy equal to 5 by 9, and we try to describe its relationship with this graph of the curve, then as x goes to plus infinity or x goes to minus infinity, on both the sides, the line and the graph will merge together. So therefore, the distance between the graph and the line approach 0 as x goes to plus infinity or x goes to minus infinity. Therefore, we can see the line y equal to 5 by 9 is a horizontal asymptote to this curve. Now, any asymptote that is neither a horizontal asymptote nor a vertical asymptote, that kind of an asymptote is known as an oblique asymptote or a slant asymptote. And for that thing, we have taken a graph here, and again we can see when this y goes to minus infinity or y goes to plus infinity, the distance between the line, which is described here y equal to x, approaches 0, or the distance between the line and the graph approaches 0 as x goes to plus infinity or y goes to minus infinity, and so on. So these are three different types of asymptotes. Now, keeping the definition of this kind of an asymptote in mind, that for vertical asymptotes, it will be a line of the form x equal to some constant, and similarly a horizontal asymptote will be a line of the form y equal to constant, and oblique asymptote will be a line of the form y equal to, suppose, mx plus c. And now let us describe the methods one by one to understand properly how we can compute these three asymptotes. But we first take the definition again here. So here a vertical asymptote can be defined as this occurs at x equal to some point c if limit x tends to c, modulus of f of x becomes infinity. So if we again look into this vertical asymptote, now as the point x gets closer and closer to pi by 2, then this f of x will approach to infinity. So if we look into this point, suppose this is the point 0 here. If suppose this is the point 0 here, if x is close to 0, then we have, suppose f of x is equal to 0. Now if we move forward, suppose this is some point c dash. If x approaches the c dash, then f of x has this distance. Now if x gets here, if x gets closer and closer to 3 pi by 2, then f of x moves to infinity. So therefore this is the then distance, this is the value of f of x when x gets closer and closer to 3 pi by 2. And the same thing happens at x equal to pi by 2. When x gets closer to pi by 2, the value of f of x goes to minus infinity. So that is how we define the vertical asymptote. And similarly, the horizontal asymptote, this occurs at some point y is equal to, suppose, L, if limit x tends to plus infinity or minus infinity f of x, if this becomes equal to L. Now if we look into this curve, when this y goes to plus infinity or here y goes to minus infinity, this f of x is this distance, this gets closer and closer to L. Now on the third step, when we are defining the oblique asymptote, so here we describe it in this way. This is a line y equal to mx plus c if the slope of, that is, if limit x tends to plus infinity or minus infinity, f of x divided by x, this becomes equal to m, which is the slope of the line y equal to mx plus c. So here if we describe this a little more, so we have this condition: a line y equal to mx plus c will be an oblique asymptote if this line and the curve behave alike at infinity. So that means at infinity, this f of x and the line mx plus c, they behave alike. So this gives, so we can write this behave alike. Now this gives this f of x divided by x is approximately equal to m plus c by x. So thus, as x tends to plus infinity or x tends to minus infinity, we have this limit x tends to plus infinity or minus infinity, f of x divided by x. Now this will be equal to m, because c by x will be 0, either x goes to infinity or x goes to minus infinity. Therefore actually oblique asymptote is a line whose slope is equal to the slope of the curve at plus infinity or minus infinity. Now let's describe the methods or the working rule for finding the asymptotes for algebraic curves. So here we have a working rule. The first one is asymptote parallel to x-axis. This is obtained by equating the highest power of the coefficient of x to 0. तो इस तरह से अगर हमें निकालना होगा asymptote parallel to x-axis, और we can see a horizontal asymptote. अगर हमें horizontal asymptote निकालना है तो हमें just इक्वेशन में हाइस्ट पावर ऑफ x देखना है, तो उसका कोएफिशिएंट हमें इक्वेट करना है 0 के साथ. जो भी वहाँ पे हमें आंसर मिल जाएगा, दैट विल बी द इक्वेशन ऑफ द हॉरिजॉन्टल एसिम्प्टोट. And similarly, second, asymptote parallel to y-axis. Now parallel to y-axis means obviously a vertical asymptote. This is obtained by equating the coefficient of highest power of y to 0. Now third, let's discuss the method for evaluating the oblique asymptote. So let y is equal to mx plus c be the asymptote. Then using the given expression, we have to find the value of m and the value of c that we substitute here to obtain this oblique asymptote. Now consider, so let the given curve be, f of xy is equal to 0. Then in this curve, we first of all find the total degree of this curve, and assuming the total degree of this curve is equal to n. So let degree of f of xy is equal to n. So this is the total degree. That means the sum of degrees of x and y in each term. Then we define a function. Now define this pi n of xy, which contains as an expression as the sum of terms of f of x y whose degree is equal to n। तो इस तरह से हम एक फंक्शन डिफाइन करेंगे फाई एन ऑफ एक्स वाई, और हम एफ ऑफ एक्स वाई की वो टर्म्स यहाँ पे इंक्लूड करेंगे इस एक्सप्रेशन में जिनकी डिग्री एग्जैक्टली इक्वल टू एन होगी। देन our next step is like this: put x equal to 1, y equal to m, which gives obtain a new expression phi n of 1 comma m। Now 1 is just a constant, so this gives us an expression phi n m, this is equal to 0। तो हमें एक नई इक्वेशन मिल जाएगी, a polynomial in m of degree n, which is a polynomial in values of m from this phi n of m is equal to 0. So that will be our next step. Then finally we can find c. So then we define the c. This is equal to pi of n minus 1 at m, which is obtained in the previous step, divided by pi n dash of m. So this is the value of c. अब यहाँ पे हमने एक पॉलिनोमियल डिफाइन किया था phi n of x y, which was obtained as the sum of terms of f of x y whose degree is equal to n। अब यहाँ पे c में जो हमने एक्सप्रेशन यूज़ किया phi n minus 1 of m, so this will be a polynomial, or this will be an expression obtained from f of x y, which is a sum of those terms of f of x y whose degree is equal to n minus 1। And then in the denominator we have this phi n dash of m। तो यहाँ पे हमें नीचे हमारी जो एक्सप्रेशन होगी phi n of m, वहाँ पे हमें डेरिवेटिव लेना है with respect to m and evaluate this phi n dash of m। So this is how do we find the three different types of asymptotes to any curve। Now let's take an example। So this is our curve for which we will find all the three asymptotes। तो यहाँ पे हम first of all निकालेंगे what is our asymptote parallel to x-axis and asymptote parallel to y-axis। So in the solution, asymptote parallel to x-axis, this is obviously a horizontal asymptote। Now according to our rule, this will be obtained by equating the coefficient of highest power of x to 0। Now if we look into our expression, the powers of x are x equal to 2, the power of x is 1 here and 1 also here, so therefore the highest power of x is 2। So coefficient of highest power of x, that is x square, is, now we have to look for the coefficient of x square here। Now first here the coefficient of x square is y, then we don't have any other x square anywhere, so therefore we obtain the equation y equal to 0 y-axis। So hence y equal to 0 is the required horizontal asymptote। Now next we find the asymptote parallel to y-axis। So now second asymptote parallel to y-axis. Now this will be a vertical asymptote. This is obtained by equating the highest power of y. So now coefficient of highest power of y is, now highest power of y is y square here, so therefore the coefficient of first of y square is minus x. Then here we have again y square, its coefficient is equal to 1, so we get minus x plus 1 equal to 0। This implies x equal to 1 is the required vertical asymptote। तो इस तरह से हम निकालते हैं asymptote parallel to x axis and asymptote parallel to y axis। तो इन दोनों asymptotes में हमें जस्ट देखना है कि highest power of x क्या है और highest power of y क्या है। Then we just have to equate the highest power of x with 0 to find the asymptote parallel to x axis, and also equate the coefficient of highest power of y to 0 to find the asymptote parallel to y axis। Now next let's consider how do we find the oblique asymptote। So now oblique asymptote, तो इसके लिए हमें क्या करना है। So first of all we let our given figure, given curve y of f of x y is equal to, जो हमने ऐसे लिखी है x square y minus xy square then plus xy minus or plus y square plus x minus y। So this is our given curve f of x y। तो इससे हम पहले define करेंगे what is the total degree। Now here this degree of f of x y, यहाँ पे हम total degree की बात कर रहे हैं because we are defining the degree of the whole f of x y and we are not here just talking about the degree of x or degree of y। अब अगर हम फर्स्ट टर्म की यहाँ पे कंसिडर करेंगे then x has power 2 and y has power 1, so total degree of the first term is 1 Total degree of the second term is also 1. The total degree of third term xy is 1 plus 1, that is 2. And y square also has degree 2. And here the total degree is 1. Here the total degree is 1. So overall in the whole expression, the highest degree is 2 plus 1 equal to 3 in the first term. And 1 plus 2 equal to 3 also in the second term. So therefore the degree of this expression is equal to 3. तो इस तरह से जो हमने अभी रूल डिफाइन किया वहाँ पे हमने n लिखा था. So our n here is equal to 3. So therefore we can define phi 3 of xy. Therefore phi 3 of xy. So now this only contains those terms from f of xy whose degree is equal to 3. अब यहाँ पे पहली term का degree 3 है, so that means we obtain x square y here. And second term also has degree 3, that we obtain minus x y square. So that is our phi 3 of xy. लेकिन अगर हमें रूल याद होगा तो वहाँ पे हमें लास्ट स्टेप पे phi n minus 1 भी यूज़ करना है. So we also calculated here this phi n minus 1 of xy. This will be equal to now phi 2 of xy, which is equal to, because n minus 1 is equal to 2 here. Now this will contain those terms from f of xy whose degree is equal to 2. तो वो हम देख सकते हैं xy has degree 2 and also plus y square has degree 2. So these are the two expressions that we need to find the value of c. So next we need to evaluate this phi 3 of 1 comma m. 1 m. We put x equal to 1 in this expression and y equal to m. तो हमें मिल जाएगा 1 square into m is m minus 1 into m square is just m square. And so this is equal to m into 1 minus m, and we have to equate this to 0. So this implies m is equal to 0. This gives m is equal to 0 and m is equal to 1. So now we have two values of m, so therefore we can get two oblique asymptotes. Now let's describe them one by one. So case number 1, if m is equal to 0, then c is equal to pi n minus 1 of 0 divided by pi n dash of 0, जो हमने ऊपर फॉर्मूला में लिखा हुआ है. So we can see here this is equal to pi 2 of 0 divided by pi 3 dash of 0. Now our phi 2 is equal to this thing. तो यहाँ से भी हम कंप्यूट कर सकते हैं what is this phi 2 of m. तो उसके लिए भी हमें x की जगह पे 1 लिखना है, y की जगह पे m लिखना है. So we get m plus m square. So we can see phi 2 of 0 is equal to 0. और यहाँ पे अगर हम डेरिवेटिव लेंगे m minus m square का, तो वहाँ पे 0 सब्स्टिट्यूट करेंगे, we will get 1 minus 0. So that will be equal to 1. So finally we get 0, 0. Hence we have y is equal to mx plus c gives y is equal to 0. So this is the oblique asymptote y equal to 0, which is actually the y-axis. So which is actually the x-axis, or we can say, so this y equal to 0 was already obtained as an asymptote parallel to x-axis. Now our case number 2 is if m is equal to 1, then c is equal to pi n minus 1 of 1 divided by pi n dash of 1. So we can see this is equal to pi 2 of 1 divided by pi 3 dash of 1. Now our phi 2, we already know pi 2 is equal to 1 plus m square, so pi 2 of 1 will be equal to 1 plus 1 square whole divided by, now here we take the derivative of pi m, which is equal to 1 minus 2m, तो उसमें अगर हम 1 substitute करेंगे, we get 1 minus 2. So therefore this is finally equal to, this is equal to minus 2. We shall edit one typing mistake in our rule. So here c is this thing, but it is negative times of this quantity, so it is minus times this. Now if we replace this minus times here also, so we still get 0, but if we replace this minus times here, we get, this is actually plus 2. So thus y equal to mx plus c gives, now here we have to add the values of m and c, so therefore this is y is equal to, now m is equal to 1, so it is 1x, then plus c is equal to 2, so this gives y is equal to x plus 2, or this is the required oblique asymptote. Now here we add one more exercise that you should practice yourself. Find all asymptotes of x cube plus y cube minus 3a xy is equal to 0.